Welcome to Maths with EJD. I've been making a series of videos on matrices, and today our attention is going to be on solving systems of linear equations using the Cramer's rule. The Cramer's rule is a method for solving a system of linear equations using determinants. And I remember talking about determinants in the video I made about matrix properties or so. Yeah, where we talked about traces and transpose and determinants. So that knowledge is going to be useful here. Well, this system involves expressing the solution in terms of ratios of determinants of matrices derived from the coefficient matrix. Okay. Now, this method is only applicable to non-singular matrices. So, of course, since the system is based on determinants, it means that whatever matrix you want, whatever system you want to solve using this method should be non-singular, meaning that it should have a determinant. And because that's a determinant, then it can be inverted. All right. Okay, so let's get into it. The first question we have is a very simple one. Um, we have to solve this system of linear equations, the 2x2 system. We have 2x1. We have 2x1 plus 3x2 equals 8, and 4x1 minus 2x2 equals 6. And we need to do that using Cramer's rule. And you know, this method is all based on determinants, right? And the way we go here is to turn the system of equations into matrix form, and this is how it goes. So for the coefficients, so the coefficient of x1 are here. So you have 2, 4, coefficient of x1. Coefficient of x2, you have 3 minus 2 that way. And of course, you have x1 and x2 this way. Definitely, if you multiply this 2x2 matrix of the coefficients and this column vector of the values of the variables you are looking for, you end up getting the system back. And of course, you have a vector of the right hand side to be 8 and 6 there. So this is how exactly you translate a system of linear equations into matrix form. So you have the matrix of coefficients, you have the vector of the variables, and you have the vector of the right hand side. Okay. Now, since we get the solutions by expressing, by getting determinants and expressing and finding the ratios of these determinants. So the first thing we do is find the determinant of the coefficient matrix. Okay. So in that way, we just call that, you can just call that nabla or whatever this is. Let me call it det, I call it this, and then that is the determinant of 2, 3, 4 minus 2. We already know that is 2 times minus 2 this way, minus 4 times 3 or 3 times 4. So that's minus 4 minus 12, and that gives us minus 16. So that's the first determinant obtained. Now, the next thing to do is to replace the column of the values of variable x1. So, variable x1 is in the first column. So the next determinant you're going to find it by replacing that column for x1 with the right-hand side, 8, 6. So now you have, instead of 2, 4, you now have 8, 6, 3 minus 2. And then again, you go ahead and find the determinant. 8 times minus 2, that's minus 16. Minus 3 times 6, that's 18. So you have minus 6, minus 18, and the answer is minus 34. So again, you have found delta 1, like I said, I should call it delta 1 or det 1, determinant 1, So that's determinant 1. So there's a normal determinant, there's determinant 1, and then determinant 2. In this case, you replace the second column of the matrix with the right-hand side. So, and that is why you have 2, 4, then 8, 6. 2, 4, 8, 6. Then again, you find the determinant. That's 2 times 6, 12, minus 8 times 4, 32. And the answer is minus 20. So now that you have done all the possible replacements you need to do, the next thing to do is to now find the ratios of matrices, the ratios of the determinant, right? So of course, the first one, x1, is the determinant of where the determinant in the case where you replaced 8, 6 in column 1, that's for the values of x1. So that determinant divided by the original determinant, the first determinant, that's minus 34 over minus 16. And that ends up giving you 17 over 8. Then, of course, x2 will be the second determinant where you replaced the second column with the right-hand side. And that is minus 20 over minus 16. And that gives 5 over 4. So finally, the results are x1 is 17 over 8, x2 is 5 over 4. Now, how do you know if your answer is correct? You can do a simple check to know that your answer is correct. Of course, the normal way in which you check for solutions of a system of equations. So of course, you have 2x1 plus 3x2. So so you put the values and see if it's okay. You have 2 into 17 over 8, then plus 3 into 5 over 4. So that means you have 2 here is 1, 2 here is 4. So you have 17 over 4 plus 15 over 4. That is 17 plus 15 is 32. This 4 is the same. So you have the final answer is 8. So, and that tallies with this. Then you also check the second one. So that's 4 into 17 over 8 minus plus okay, it's minus 2 into 5 over 4. So that is 4 here is 1, 4 here is 2. So you have 17 over 2 minus 2 here is 2 here 1, 2 here 2. That's 5 over, sorry, that's looking like 3. So 5 over 2. 17 minus 5 is 12. 12 divided by 2 is 6. So that means your answers are correct. So that way you can check that your answers are correct. Or maybe I should just leave that, right? Let me leave all that. So you can check to be sure your answers are correct. And from here, we see that the answers are correct. So that's a 2x2 case. Let's move on to a 3x3 case. So for this 3x3 case now, again, you're solving x plus 2y minus z equals 5, 2x minus y plus 3z equals 12, 3x plus 4y plus 2z equals 20. Of course, using the Cramer's rule, since this is what this video is about. Again, you form the matrix of coefficients. That's 1, 2 minus 1 here, then 2 minus 1, 3 here, 3, 4, 2. That's the third row. And then, of course, the variables are going to be x, y, z, a column vector, and then the right-hand side, 5, 12, and 20 is also a column vector. So with this, you have the system in matrix form. And since you're using Cramer's rule, of course, the first determinant you should look for is the determinant of the original of the matrix of coefficients. So here, you just have the first determinant. That's the determinant of this. And of course, we've done this before. So you assign plus, minus, plus, because those are the signs that are attached to those to those elements. So then you say plus 1 and you cross where that plus 1 belongs to, and you have minus 1, 3, 4, 2 here. So that's done. Next thing, you have minus 2, this minus 2, and that's what is here. And then you cross the column to which it belongs and the row to which it belongs. What do you have left? 2, 3, 3, 2. And that's why you have this here. Okay, then the last one would be that would be plus minus 1, right? Plus minus 1 is minus 1. That's why it's just minus 1 here. And then you cross the row and cross the column. So you have 2 minus 1, 3, 4. So this 2 minus 1, 3, 4, that's what you have here. So once you're done doing that, you can now begin to simplify further. So you have plus 1. Since you've done it before, I'm not wasting time with this. So I just say minus 1 times 2, that's minus 2. Minus 1 times 2, minus 2. Minus 4 times 3, that's 12. So minus 2 minus 12, you have minus 14. Then this minus 2, this is it. Then for this, you have 2 times 2, 4. 4 minus 9, that's minus 5 here. And then this is minus 1 into 2 times 4, 8. 8 minus 3, that is 8 plus 3. And that is why you have 11 here. So with that done, we move on again and we say plus 1 times minus 14, that's minus 14. Minus 2 times minus 5, that's plus 10. Minus 1 times 11, that's minus 11. And then if you tidy that up, you have minus 15, because minus 14 plus 10, like I was explaining in one video, minus 14 plus 10 is like you're owing 14 and you have 10. If you pay 10, you still are owing 4. So now you're owing 4 and you're now owing 11. That means you're owing 15. That's minus 15. So with that, we have the first determinant. So the second determinant would be you replacing the first column 1, 2, 3. You want to replace the column of the values on the right hand side with that first column. And that is why here you have 5, 12, 20, overwriting 1, 2, 3. And then you have the other ones normal. So 2 minus 1 minus 1, 3, 4, 2. So that's the next thing to evaluate. So that I call this one det x, because we are replacing the column for x with the right hand side. Call it det x. So again, we have the signs attached. That's we attach signs to that. That is plus, minus, plus as usual. So we have plus 5 cross this and this. You have minus 1, 3, 4, 2 here. Then the next thing is you have minus 2, this minus 2, and then you cross the column, cross the row. That's 12, 3, 22, 12, 3, 22, and that's what you have here. So again, you go for the last one. That's plus minus 1, which is still minus 1. Plus and minus is minus. So you have minus 1. Cross the column, cross the row. You have 12 minus 1, 24. This one there. So again, we go ahead to simplify all of that. And that's plus 5. Of course, that's just 5. Minus 1 times 2 is minus 2. Minus 12, that's minus 14. Then minus 2 is still out here. 12 times 2 is 24. 3 times 20 is 60. So 24 minus 60, that's minus 36. Then minus 1 here. 12 times 4 is 48. 48 minus 1 times 20, that's minus 20. So that's 48 plus 20. And that's why you have 68 here, So with that, we've simplified that. Then we move on. 5 times minus 14 is minus 70. Minus 2 times minus 36 is minus times minus plus. 2 times 36, 72. Minus 1 times 68 is minus 68. If we add that up, minus 70 plus 72, that's minus 2. Minus 2 minus 70 plus 72, that you're owing 70, but you have 72. You pay 70, you have 2. That's plus 2. So plus 2 minus 68. You have 2, but you're owing 68. So you're still owing 66. That's why you have minus 66 there. So that's delta x. So the next thing, you replace the column for y, what I call det y now. You replace the column for y with the right hand side. So instead of having 2 minus 1, 4 like before, you just have 5, 12, 20. And the first column, 1, 2, 3 remains the same. The column for x and the column for z remain the same, So in that case, you now have 1, 2, 3 column. First column 1, 2, 3. Second column 5, 12, 20. Third column minus 1, 3, 2. And then we go again. This is plus, minus, plus, and then again plus 1. Cross this. You have 12, 3, 22. Then you cross for the next one. You have minus 5, which is here. Minus 5. Then cross the column, cross the row. That's 2, 3, 3, 2, which you have here. All right. And then you also go ahead to have the last one. This is plus minus 1, which is minus 1 as expected. This cancels this. I mean, cross the rows and row and column. You have 212, 320 coming here. And then you try to tidy all that up. Try to tidy all that up. So you have plus 1 into 24 minus 60, that's minus 36, minus 5 into minus 5, that's 4 minus 9. Then minus 1 into 40 minus 36, that's 4, So you have minus 36, minus and minus plus 25, minus 1 times 4, that's this. So minus 36 plus 25 is minus 11. Minus 11 minus 4 is minus 15. So with that, again, you've got the third determinant, which is that y, and then you can go on to find that z. So in that case, you replace the column for z with the right-hand side. So instead of the previous minus 132, you just have 5, 12, 20. So, and again, you go plus, minus, plus normally, and then plus 1 here into cross this and this. You have minus 112, 420 here. And then you have the next thing to be minus 2, which you have here. Cross the column, cross the row. You have 2, 12, 3, 20 right here. Okay. So next you have plus 5. You have plus 5. That's what you have here. And then cross the, plus 5, cross the column, cross the row. You have 2 minus 1, 3, 4. And that is what you have right there. So again, we tidy things up. And then we have plus 1 into minus 20 minus 48. That's minus 68 right here. So you're owing 20 and you're owing 48. That's owing 68 altogether. So that's minus 68. Then minus 2 is it here. 2 times 20, 40. 40 minus 36, that's 4. And then you have plus 5. 2 times 4, 8. Plus 3, that's 11. So 8 minus 3, that's 11. And then you go ahead to tidy that up further. So this minus 68, minus 8, and then plus 55. And minus 68 plus 8 is minus 76. Minus 76 plus 55, you are owing 76 and you have 55. If you pay the 55, you still have 21 that you're owing. That's minus 21. And then now that you have delta, delta x, delta y, delta z. So you should know that that x can be found by saying delta, by finding the ratio of delta x and x. That's minus 66 over minus 15. So 3 goes here 22 times, and 3 goes here 5 times. That's why you have 22 over 5. Then the next one is y. So y is delta y. Of course, delta y is minus 15. Delta is also det y is minus 15 rather. And the original det is minus 15. Minus 15 divided by minus 15, that's 1. So that's the answer there. Z is delta z over delta, det z over det. That's minus 21 for delta z, which we just got now, divided by minus 15, which was the first one. And, minus divided by minus is plus. 3 goes here 7 times. 3 goes here 5 times, and the answer is 7 over 5. Therefore, you have this conclusion that the solution to that system of linear equations is x equals 22 over 5, y equals 1, and z equals 5. So, I mean, you just need to be calm. Matrices are simple, but they can be, because of the many arithmetics you have to do, you can easily mix things up. So you just need to be very calm while doing this. So to try your hands, you can check out this exercise. Solve the following using Cramer's rule. A, 2p plus 3q equals 8. 4p minus q is 5. B, x1 plus x2 plus x3 is 6. 2x1 minus x2 plus 3x3 is 2. 3x1 plus 2x2 minus x3 is 7. So you want to try your hands on that so you can see how well you understand what I've explained so far. Thank you so much for listening. See you in the next video where I talk about solving systems of linear equations using matrix inversion method. Bye.